All right, so we are on 9.6 double integrals. So in order to think about double integrals, we need to think about we did partial derivatives where we held one of our variables constant while we took care of the other. Well, we're going to do the exact same thing here with double integrals when we do integration. So for the first definition that we have, if f of xy is defined over the rectangular region R bounded by x equals a, x equals b, y equals c, and y equals d, then the double integral of f of xy over the region R is given by the integral from c to d of the integral from a to b of f of xy dx dy, or the integral from a to b of the integral of c to d of f of xy dy dx. So, yes, that looks ugly, sounds ugly in everything that we do, but let's break it down what we're really going to do. So, first, what we're really going to do, if I can write clearly, we are going to work inside out no matter which way we're given. So we're going to take care of that inside piece first. We're going to integrate the function f of xy with respect to x if we're on the left one here. Then we would get our answer using the fundamental theorem of calculus, and then we would integrate with respect to y and then use the fundamental theorem of calculus. On the second one over here, we would integrate f of xy between c and d for du sub y, so with respect to y. Then we would integrate that answer after using the fundamental theorem of calculus with respect to x, and then we would integrate that inside the limits between a and b. So really what we're talking about, if we're talking about a region, so if we have our thing here, really what we're talking about is some rectangular where here's a, here's b, here's c, and here's d. So only thing we care about is what does our function actually do inside of this region right here. I don't care anything else except for what's inside those bounds right there. So our first example here is now sometimes we can have places where our function will be defined in terms of variables. So anytime that you have that, you must do that inside piece first to get your variables out there. Because if you do it the other way, you're still going to have variables inside your answer. In general, we do not want to have answer variables inside of our answers. We want to have numbers in the end. So how do we do this? So the integral from 0 to 1 of the integral from x squared to x of xy squared dy dx. So notice the first thing I'm going to do is I'm going to break this apart. First thing that we care about, we only want to worry about this inside piece, the integral from x squared to x of xy squared dy. So once we do that, note, remember, we are with respect to y right now. So since we are with respect to y, everything else is a constant. So if I bring that x all the way on the outside there, I integrate my y squared. The integral of y squared is y cubed over 3. And then we're going to evaluate the y variable from x squared to x. So if we rewrite this a little bit, we make this 1/3 x times y cubed evaluated from x squared up to x. So that's what we're looking at doing right here. So when we plug in x squared, or when we plug in x for everything, we get x cubed. We plug in, and then we subtract when we plug in x squared by the fundamental theorem of calculus. So we would have 1/3 x times x cubed minus x to the 5th. X to the 6th, sorry. It's all right. It's just an algebra mistake. We all make mistakes. So when we do that, we then x times x cubed gives us the x to the 4th in the next one. X times x to the 6th gives us x to the 7th. So that is if we just did the inside piece. So we're not through with this problem yet. We've only done half of our problem. So now we need to take this new function, 1/3 x to the times x to the 4th minus x to the 7th, and we need to integrate that from 0 to 1. Since 1/3 does not have any type of variable with it, we can factor it all the way out and then just integrate it. But we can't forget about that 1/3 in the end. So we'd have 1/3 times brackets of x to the 5th over 5 minus x to the 8th over 8, evaluated from 0 to 1. So when we simplify this, we're looking at 1/3 times 1/5 minus 1/8 minus 0, because 0 to the 5th is 0 over 5, 0 to the 8th is 0 over 8. So we end up with basically 1/3 times 8 over 40 minus 5 over 40, which is 1/3 times 3 over 40. Our 3's can cancel out, so we're left with 1 over 40. So our entire double integral from 0 to 1 of the integral of x squared of the x of xy squared dy dx is equal to 1 over 40. So sometimes we're going to have to set them up and everything. So in this case, find the double integral over the rectangular region R with the given boundaries. So anytime that we see this type of notation here, they're not telling us our limits here, but they're telling us the order. They give us dx and dy. In a case like this, does it really matter? No. As long as our limits here, 0, 3, 1, and e, as long as none of those are variables, we can switch order of integration and it does not matter. Just like when we did partial derivatives, f sub xy should always equal f sub yx. Same exact theory here with antiderivatives or integrals, as long as you don't have variables. So by this standard here of the double integral of x divided by y dx dy, we need to rewrite this using what we have here. So this is the double integral. We're going to do dx first, or on the inside, and dy on the outside. So y goes from 1 to e, x goes from 0 to 3 of x over y dx dy. So when we integrate that, we're going to get the integral from 1 up to e is still going to be on the outside. So let's worry about this x. So this is going to be x squared over 2y evaluated from 0 to 3. And then we're going to have our dy. So this is the integral from 1 to e of 3 squared over 2y minus 0 squared over 2y dy, which this equals the integral from 1 to e of 9 over 2y dy. So now we need to finish out our integration here. To make it a little bit easier to see, I'm going to make this 9 over 2 integral from 1 to e 1 over y dy. We know that the antiderivative of 1 over y is a natural log, so this is going to be 9 over 2 natural log absolute value of y evaluated from 1 to e. So this is 9 over 2 times ln of e, ln absolute value of e, minus ln absolute 1. We know that ln and e are inverses, so they cancel out, leaving us 1. ln of 1 is 0. So therefore, our answer here is 9/2. We can see that by coming back over here, and they do the same thing. I do the same thing over here. I just wrote out a little bit further steps and everything over there. So as our last example here, find the doubled integral over the given region of the double integral of 4 minus 4x squared for x between greater than or equal to 0, less than or equal to 1, and y greater than or equal to 0 and less than or equal to 2 minus 2x. Now, since we have that one of our variables is in terms of the other one, so y is bounded by 2x, we have to do y first because I can't plug in values for x and then still have x's left in my function here. So my y is bounded between 0 and 2 minus 2x, and then my x is going to be bounded between 0 and 1. So we need to integrate this with respect to y. So 4y minus 4x squared y between 0 and 2 minus 2x. Plugging in that 2 minus 2x, it's 4 times 2 minus 2x minus 4x squared times 2 minus 2x. 0 doesn't do anything for us. So in here we get 8 minus 8x minus 8x squared plus 8x cubed. So we end up with 8x cubed minus 8x squared minus 8x minus 8. We're then going to integrate this from 0 to 1 dx. So integrating that, we're going to get 8x to the 4th over 4 minus 8x cubed over 3 minus 8x squared over 2 minus 8x, all evaluated between 0 and 1. So plugging in 1 everywhere, we're going to get 8 over 4 times 1 to the 4th minus 8 over 3 times 1 cubed minus 8 over 2 times 1 squared minus 8 times 1. So 8 divided by 4, so we get 2 minus 8 thirds minus 4 minus 8. So we end up with minus 10 minus 8 over 3, which gives us minus 38 over 3 as our final answer. Which is not what I got over here. Let's go back and double check this real quick. Oh, I missed a sign right here. This should have been plus 8. So plus 8x plus 8 plus 8. So therefore, this should have been 10 minus 4, which is 6. So this would have been 18 minus 8 over 3, which is 10 over 3. This is why you had to be careful when you're making videos and everything. So simple mistakes can get us. We have to watch out for those and everything. So be aware of that whenever you are working through things.